Why these statistical tools matter. Whether you're building dashboards, running predictive models, or presenting to executives, understanding complex statistical methods like regression, correlation, and causation isn't just a nice-to-have, it's essential. These tools help us go beyond the what of data and get to the why and what next. In this video, I'll break down the real-world applications of these three powerhouse techniques: regression, correlation, and causation, so you can use them with confidence in your next project. Let's start with regression, the backbone of predictive analytics. At its core, regression helps us forecast an outcome based on one or more variables. Think of it like this. If you feed the model enough context, like past sales, weather, and marketing spend, it'll try to predict what comes next. Common types: linear regression for straight-line relationships, multiple regression with two or more independent variables, logistic regression when the outcome is categorical, like yes/no. Example: you're a data analyst in e-commerce. You use multiple regression to predict next month's sales based on ad spend, email click-through rates, day of the week. This isn't just guesswork, it's data-backed strategy. Bonus tip: always check R-squared and p-values to evaluate your model's reliability. A high R-squared means your model explains a lot of the variation, but don't get too attached. Overfitting is real. Now let's talk about correlation, the tool we use to measure how strongly two variables move together. It's not about cause, it's about connection. Example: say you're analyzing product returns and customer reviews. You find a negative correlation between average review score and return rate. Lower reviews, more returns. Makes sense, right? But here's the thing: correlation doesn't mean one causes the other. It just tells us there's a relationship worth exploring. Correlation coefficients. +1 equals perfect positive correlation. 0 equals no correlation. -1 equals perfect negative correlation. Use Pearson for linear relationships, Spearman if your data isn't normally distributed, and always visualize your findings with a scatter plot. Here's where it gets tricky: causation. It answers the golden question. Did A cause B to happen? We crave this certainty in business. But proving causality requires more than a good chart. It requires rigor. Real-world example: your company rolls out a loyalty program. 3 months later, revenue jumps. But was it the loyalty program? Or maybe it was a holiday surge? To test causality, we need to eliminate outside factors. Techniques that help: A/B testing. Randomly assign users to two groups and compare outcomes. Difference in differences. Compare changes over time between treated and control groups. Instrumental variables and propensity score matching. Advanced tools to handle hidden biases. When you can prove causality, you give decision makers confidence. That's what sets expert analysts apart. In reality, you rarely use these methods in isolation. The real power comes when you layer them together. Here's a practical flow. Start with correlation to identify potential relationships. Use regression to predict or quantify impact. Apply causal inference to validate strategy or policy change. Example scenario: correlation shows higher engagement is linked to higher sales. Regression predicts sales based on weekly engagement data. A/B testing confirms that sending personalized emails causes more engagement. That's a full analytical loop, from signal to strategy. Let's recap. Regression helps us forecast and model relationships. Correlation shows us which variables are moving together. Causation proves what's actually driving results. As a data or BI analyst, these tools are more than just formulas. They're how we tell stories, influence strategy, and create real impact. Use them wisely, use them together, and always question what the data is really saying. If you found this video valuable, hit like, subscribe, and drop a comment below. Which method do you use most in your analytics work? Until next time, keep your insights sharp and your logic tighter.